So today's topic will be the double stub matching, right? We'll directly start with the problem. Okay. So match a double stub. Okay. Perform the impedance matching of the ZL equals to 80 minus J40 connected to a transmission line of Z0 is equal to 50 ohms, right? Using a double stub matching network. Normally, you see, I'll try to draw a representation diagram for the first problem only. Later on, will not do this. Okay, so let us assume what are the terminologies we are going to use here, like we did for the single stub case, right? So normally we have uh, so we will be having a R. Sorry, it's not R. Sorry, I'll write a Z. Not just resistance, impedance. Load impedance is present. Let's say that is ZL. What we normally do is you convert that into a YL, right? ZL gets converted into, okay, I'll write a small letter so that we don't get confused. Anyway, ZL gets converted into small ZL, right? I have a normalized, that is ZL. It will be converted into YL, correct? So you are okay with that? That's a normal process. Okay, now we have to design the double stub matching network. So let me assume that I'm connecting one stub here. So this is the first stub. So I'm also connecting that to maybe over here. Let's assume this is the other stub. Maybe I'm connecting here. Okay, so that is getting connected to this point. Okay, so we have two stubs to be connected. Now there are two types of problems available that might come. Okay, so I will discuss about both the types. So uh, the notations that we are going to follow will be like this. So anyway, I have a YL given. I'll convert. Sorry, ZL given. I convert that into YL, and from that YL, right? What we are trying to do here is I'll try to calculate the impedance of the stub. Okay, impedance related to stub, that means it is getting converted into the Y of the stub. Okay, so how do we do that? We have to consider the separation between the two stubs. This is what is important for us. Okay, so the separation between the stub will be given, that is the two stubs are separated by, again, that value will be in the form of lambda, like lambda by 8. Okay, or the lambda by whatever, right? 3 lambda by 8, any number may come there, right? Uh, we have to use that. Okay, so we have to use that distance which is given, right, to find out what is called as the y1 which is present over here. I'll write here, this is the first step. When you look into this, I'm going to call that as y1. Okay, similarly, when you look into this, it will be the y, this is y2. Okay, right, y1 y2 will be the two values, and a distance between the stubs will be given. I'm going to call that as a d. Okay, fine. Next part will be I need to calculate the susceptance value of the stub. So that is when you look into this, I'll get what is called as a complex number. That is, I'll call this is JB1. Similarly, when you look into this stub on the other side, I'm going to call that as JB2. Right? These are the two values which we are supposed to get, right? So that we can compensate. All right. So we have to do this, right? This is our ultimate goal, right? I'll try to zoom out and show what we have written so far. So this is our overall idea. I have to have the two stubs and I need to use both the stubs to match. Ultimately, when I come here, right, here I'm going to get something like 1 minus JB2. To cancel that, I'll get a JB2, right? The first Y1 will not be in the required form. Okay. Uh, when we solve the problems on the single stub, directly we got the required form, right? But in this case where we don't have the single stub matching, we will go for a double stub matching problem. Practical cases are there where you cannot use a single stub because of the physical conditions. Okay, because of the physical conditions we may not be able to solve directly. Okay, so that's the reason why you should go for a double stub matching problem. Is it okay? All right, so now let's do one thing. Let's start the problem. I'll bring the this thing. Uh, yeah, I'll get the Smith chart first. Right. So this is the Smith chart. Let's expand. All right. So we'll start the problem with the given values over there. So we can see that they have already mentioned that the Z, let me write a small ZL directly, which is capital ZL divided by Z, right? So I will calculate. ZL is given, which is 40. Is it 40? No, right? It's 80 minus J40. So 80 minus J40 given, divide that by 50. So 80 by 8 by 5 is 1.6. 40 by 50 is 0.8. So minus J 0.8. All right. So what we do, we directly mark that, right? So 1.6, 1.6 is here, and minus J 0.8. I think this point maybe. This is 0.8, this is 1.6. Yeah, so this is the point which I'm going to mark. This is the ZL, the small ZL. Okay. All right. Now, as usual, right, what I'm supposed to do, you take that as a, okay, I can even draw a line passing through this, and I have to pass through this, reach the other side, and I also have to draw a circle, right? That is the constant VSWR circle corresponding to this particular uh, this given line. Okay, this given transmission. Maybe I'll just draw like this and I'll check. All right, so we got this point. So what is the other point? This point itself will be the YL. Okay, once you calculate your YL, please let me know. Okay, so the YL comes to be how much? 0 plus J 0.28. All right, so this is the first step. This is common between in any of the problem we solve. Okay, now we deviate from what we already have done. Okay, so what we do, we use the distance. Okay, we use the distance uh, distance given, right, between the stubs. Okay, so let me just check in this problem how much is given. It's not given, so use distance between the stub. D is equal to I think we are going to use lambda by 8. Okay, so this will be given. I'll tell you what you are supposed to do, right, for any given value. So use this as the next step. So let me come back. So they have mentioned that the distance d is equal to lambda by 8. So lambda by 8 means how much? What is 1 by 8? 0.125, correct? 0.125 lambda. Okay, so here recall the previous step. In case of in the previous step, I used to, right, consider this circle, correct? Now this is the circle that we are going to consider for the original or the transmission line which we are considering. Okay, whatever transmission line uh, we are considering in the problem, this is the r equal to 1 circle of that. Okay, but whenever I move by a distance equal to given distance, this circle also should be shifted by that much amount. Okay, so that's the meaning. So I see that now I have to move a distance of 0.125 lambda. Okay, now you see I'll make a difference. If at all they had asked that uh, rotate it, so distance between them should be, say, d dash is equal to 3 lambda by 8, then what is the value? Can you tell me what is 3 by 8? 0.36? 375. 375 lambda. Okay, so you will move by this much distance, that's all. Okay, you have to move by this much distance. That's the difference. Whatever value they give, they may ask lambda by 10, no problem. Okay, any number given, you just consider that as the distance that you move. Now there is a rule to move, right? I am trying to move this circle. Always you will move that in this direction only, right, in the anti-clockwise direction. Okay, you are moving this in the anti-clockwise direction, right? For any problem, whatever distance they mention, you move by so much amount, and that is always in the anti-clockwise direction. Okay, so just remember that one point. Okay, now, so you see, you consider this as your reference point. Okay, from here I should count 0.125. So you keep counting 0.125 here. It actually comes to the actual 1.125 itself if you are looking at the outermost circle, correct? Distance I want to cover is 0.125. So total is how much? Total is 0.25, correct? Half circle is 0.25, right? I'll come back. I'll repeat. Now the complete circle, if you rotate, what is the distance that you are covering? It's 0.5 lambda, isn't it? In the sense you rotate this complete, you see this is 0, right? Once you make a complete circle, how much is that? That is 0.5, right? Correct. So you're not able to recall that complete circle. If you, it's 0.5 lambda, right? Okay, so if at all I want to move 0.25 lambda, how much you should cover? You should cover half the circle, half of the Smith chart. Is it right? Okay, now you see I want to cover 0.125 lambda, which is half of my half circle. correct, which is one fourth of a circle. So that means I need to move 50%, right, of the half circle. In the sense, one quarter I need to move. So I need to rotate this particular circle by one quarter of my whole circle. One quarter means how much, right? You can actually measure this directly. I don't have to do such a difficult mathematics here. Consider this as 0. Okay, in this direction I need to move 0.125, so that will be actually 0.125, this point somewhere here. Is it right? Because you can see that this is 0.12, this is 0.13, so 125 is at the middle, right? Okay, right. If at all this number is like the 0.36375, you would have come over here, the lower half, right? So somewhere here will be the 0.375, not may not be there. So maybe here or here somewhere, right? Is that okay, right? So if at all it is lambda by 10, so zero point 0.1 lambda, so just move by 0.1, that's all, right? So this is 0, consider this to be 0, right? This is 0.25, right? 0.15 will give you 0.1, correct? I think where is 0.1, 131415. You see, this is the 0.15. So if you cover this much distance, if at all they gave, the gap between the two stubs should be zero point 0.1 lambda. This is what you're going to do, correct? That's all. Okay, right. So anyway, we'll solve various problems, different types also, so that you will come to know, right, how much to move. Okay, all right. So that's done. Now I understood that in this case I have to move by 0.125. So measure is 0.125. Okay, so that comes somewhere here. 0.125 is this one. Okay, I'll draw a radius from the center to this. Okay, this will be my radius now. Is it okay? Now, so I have to rotate this circle to this point. You see, right now my center is here. Okay, center of this red dotted circle is here, right? This center should be moved onto this. Okay, so how do I do that? Anyway, I can find a center of the circle, right? I can, right, use the tools to get the center value. Maybe somewhere here you get the center and then draw a circle. That's all. Okay, so keeping that point, try to draw a circle. So this is my new circle. I'll try to, so now you see I actually have moved my circle to the new position. So this is the next thing to do, right? So find out what is the distance between the two stubs and rotate the constant r circle, r equal to 1 circle, right? Move it by that much amount, right? Like this, in the anti-clockwise direction only. Is it okay? Fine. So in the next step, what we are going to do, we will be, I have a YL which is marked over. Okay, so that particular YL, I want to move that YL by a distance that is equal to, okay, let me on the same line. You can see this YL actually passes through, let me say, uh, okay, there is a imaginary value associated with the YL. For example, you have two options to do. You can do anything you want, like you can go with this line. Okay, this is one option. One option is this, you can go like this and touch your this over here. This is one option. Other option is this side. You take any one. Okay, so this is the point. Okay, intersection of your YL's imaginary line, right? not imaginary, sorry, the real line, you make it to touch the shifted circle. Okay, right, anyone you want, you take. I'll stick to the closer one, so I'll remove this part. Okay, so anyone will work fine. Okay, answers will be different, but both will be the right answers. Okay, so you consider anyone which you want, absolutely fine. If you take the other point, you'll get a different answer, but right, irrespective of which one you take, it's fine. Now this is the y1 form. Okay, so the red color which we have marked is y1, so read me the y1. So the y1 value comes to be 0.55, 0.05, is it? Okay, so this is plus j 0.05, isn't it? Okay, so that's fine. So we get the value like this. Now, if at all I go to the other side, I will get a different value. That's all. Okay, you can go with that as well. Fine, but the method remains same, irrespective of which one you choose. Now, once I have y1, I can directly get the JB1. JB1 is nothing but the impedance corresponding. Sorry, the susceptance corresponding to this. Now you see, we got y1. I am supposed to calculate the JB1. Okay, so JB1, simply apply the formula. JB1 is whatever the y1 I got, from that I should subtract the YL. Okay, so y1, simply put that 0.55 plus j 0.05. From that, subtract. I think you have a small this thing, because you see, if the YL is 0.5, okay, the Y1 also should have the same 0.5, okay, because it's the same line I'm moving, correct? Right. So it should be 0.5. Right, it's always okay. So I'm expecting a imaginary answer, purely imaginary value, so this will be 0.5. Okay, so 0.5, this number, this is y1 minus 0.5 plus j 0.28. Okay, so that becomes j, it's minus j 0.23. Is that fine? Just verify once. No, I subtracted. So you see, I'm supposed to subtract the y1 minus yl. So y1 is this, yl is this. 0.05, 0.5 will get cancelled. Okay, and 0.05 minus 0.28 is how much? Maybe I made a mistake here, so just do a calculation. So this is wrong. Okay, just subtract. So I have to 0.28. Yes. Okay, the same answer, right? Okay, so that is equal to uh, this is equal to minus j 0.23. Okay, so that is the susceptance of the first step. right? Directly we got that. Y1 minus YL. So this is the equation you just have to remember, right? You calculate a YL first, YL comes first, then drop it onto the newly shifted circle, either left side or right side. Anyone, you stick to the same thing, right? Okay, you get a Y1. So Y1 minus YL will be the susceptance, that is B value of the first step. Yeah, whichever side you move doesn't matter. Okay, right. So always you stick to the same side. Now you, anyway, we are doing on the left side. Always you stick to that. Otherwise, you may have some confusion, right? Whether to go left, right, or something. Okay. Now the second thing is that I need to convert. You let me go back to the. So I need to move by a distance, right? Such a way that I would get something like 1 plus j something. Okay, 1 plus jx, right? So that I can cancel the jx, I can get a minus jx here to cancel that. Okay, so that's my fundamental idea now. So in order to do that, what I do, it's very simple, right? You have the y1 which is present, right? Y1, uh, connect the y1 to the center, or connect y1 to the origin. So that's what I'm trying to draw now. So this is what you connect. This should be your radius now. It's a new value. Okay, it is a new radius. Keeping that as a radius, draw a circle. Okay, I don't know whether mine will be proper or not. I'll try to make sure that it's okay. I want this to be slightly larger. Okay, somewhat. Okay, you can see the difference, right? There is a smaller circle which I have drawn. Okay, now, so you have to move on this circle, right? It's like I'm going back to the original circle, right? I had moved, I had shifted my r equal to one circle by this much amount. Now I want to go back. Okay, so this is what I'm doing now. I'm going back. So going back in the sense, not along the original path in which we came. I am supposed to move in the newly drawn circle. See, in this problem it may look complicated, but maybe other problems you will be able to draw this, trace it until you reach your original circle. So that means I am going to reach this point. You can see a point here, red color mark, right? That is the y2. Read the value of y2 for me. Okay, once you do that, just read me the value y2. You see that you got answer. So once you read a y2, you'll come to know that yes, I got my answer. Read it and tell me, then we'll discuss. Okay, so the y2 value comes to be, as of now, how much you're getting? 1 plus j 0.5, correct? Now you calculate the jb2, right? So the jb2 equation is pretty straightforward. I'll just show you the jb2 once. So jb2 is the b value of this term, which has to be present so that you will match. Okay, so jb2 equation is 1 minus y2, that's all. Okay, so that is equal to 1 minus 1 plus j 0.5, that is minus j 0.5. So we got two susceptances. The b1 value is equal to minus 0.23, right? And the b2 value, right, is equal to uh, minus 0.5. Is it fine? Okay, so since both are negative, I have to mark them in the lower half of the Smith chart, correct? So let's look for those points. It's an innermost circle which you are supposed to consider, correct? So you see that one of the value is minus 0.23. So so where is minus 0.23? Minus 0.2, 0.3, so 0.25, maybe closer to that. So this is the one point. Okay, and the other point is, yeah, in the inner circle, correct? So it's a x value circle, x value value. Okay, so this is the 0.5. Are you okay with that? Okay, so corresponding to them, I need to measure the distances. Okay, so what you do, you connect them to the center. This is one value, and this is the other value. Are you okay? So just read them for me, and then we'll measure the distance. So I'll write the values over there. So this is minus j 0.23. This is minus j 0.5. So corresponding to each one of them, we need the lambda values, right? You can measure on the outermost circle, no problem. Okay, for the first one, 0.462, right? And the 462 lambda, perfect. Zero point 426 lambda. Okay, now what I'm supposed to do, I'm supposed to measure from this point which corresponds to infinity, correct? So that is equal to, right, 0.25 lambda, right? I want to measure the distance from here to here, so that is 0.426 minus 0.25 is the length of the second step, b2, right? So b2 corresponds to the l2, b1 corresponds to the l1, correct? Length of the first step and length of the second step, we can simply calculate in this. So therefore, let me write L1 is equal to 0.462 minus 0.25 lambda. So what's that answer? 0.212 lambda. Okay, similarly calculate the other one, that is L2 should be 0.426 minus 0.25. 176 lambda. That's the required answer. Is that okay? Do you have any doubt with this particular problem? Okay. So this distance, right? You are asking about the current distance of the stub, correct? Okay. So stub is always connected to this is the point where y is equal to the infinity point is here, correct? The point is infinity because I have a short circuit, correct? The stub is short circuit. Short circuit means z is equal to 0. What is y? Y is 1 by 0. That's why infinity, correct? So I am supposed to measure the distance of this much value, j minus j 0.5, from the point that is equal to infinity. So that's why I'm measuring this distance. Is it okay? Because I'm using a short circuited stub. So short circuited stub means the y is equal to infinity point should be considered for the measurement. Is that okay? Huh. It's 0.5 when you completed a one complete circle. Otherwise, if you are considering that as a starting point, that is 0. Okay, so this side has 0 as well as 0.5. So you will be making it 0.5 only when you complete one circle. Otherwise, it is still 0 only. It's a zero only. As of now, it is zero. I have never completed the circle even once, right? Okay, sorry. Okay, so you see here, so far what happened, we started with zero, right? I moved 50%, that is 0.25, and I'm coming further. I reached my minus j 0.5. So I have never completed a circle. I further moved and I reached this point. Still, I have not considered I have not completed a one circle, correct? So there is no question of crossing 0.5 in this problem. Huh. This 0.462 is measured right away from the beginning, starting from zero. You are moving on the outermost circle, correct? So that's why you get 0.462. When hmm, that is because the 0.25 is measured from where? Sorry, I'll move once again. Yeah, 0.25 is measured from 0 till here, correct? And 0.462 is also measured from 0 till here, right? So you see, I just want, yes, that's all. Right. That's all. That's the concept. Okay. So if you have to subtract a 0.25 because that is common between both the measurements. If you right, if you use the inner circle, you have to apply a slightly different logic. That's all. Right. Stick to anyone. Right. You don't have to consider both of them. You can use either the inner circle or the outer circle. No problem. One and same. But inner circle is slightly different logic because you see, you start from 0.5, the reverse direction is increasing, current direction will be decreasing. That's all. There also will do the same thing. Okay, I'll show you. If you use the inner circle, this point is how much? This point is 0.25. Okay, inner circle. This circle. Okay, the one which is between. So instead of 0.462, you have some other value that is read on this point. Correct? So in that case, you will subtract 0.25 minus whatever value here. Right? That gives you the distance. That's all. Because, right, I have a common thing which is different than what is the previous case. If it is confusing, don't consider that, right? Otherwise, you will get outer one. That's fantastic. That's fine. Okay. Any one you consider. Okay. So, all right. Let's move on to the next problem. I'll give a problem for you to solve. You take your time. You solve. Then we'll discuss. Is it okay? All right. So, uh, this is the next question. So, ZL is equal to 60 plus J40. Z naught is equal to 50 ohms, and the distance between the stubs is lambda by 8. Please try to solve this, then we'll discuss the problem. So the normalized values are like this. So we get that is ZL equal to 1.2, is it? Okay, 1.2 plus 0.8. So 1.2 plus 0.8 is this this is 1, this is 9, this is 0.8. Okay, so 1.2 plus will be somewhere here, I guess, right? This value. Okay, so what we do initially, we'll draw a circle, right? And we'll convert that into admittance value, y value. Okay, so tell me how much you got here as a y value. So this is ZL. Here I have a YL. So YL is equal to, can you repeat? 0.55 minus J 0.3, is it? Okay, approximately, right? So next, I have to move my circle by appropriate amount, correct? So we'll be moving that to, it's like they have mentioned that it is the gap between the two stubs is lambda by 8. So as usual, so you start from the center and draw a line, this 12 0.125, and keeping on that line at the center, I have to keep this thing, right? So let me zoom that close enough. Let me try it. Yeah. So this is a circle which moves, right? So now this YL which I have here, right? So I need to move this YL along the same line so that it touches. Okay, so let me zoom this. So look at the R value, whatever is the R value you have, move on the same R value. So R value, I can see that this something like this. This is the R value circle, right? Constant R circle for the given YL, right? So that's what. So it touches my new circle at this point. So this is the Y1. Okay, so what's the Y1 value? You just tell me. Okay, how much we have? The what's the value of Y1? Okay, Y1 is not that, right? Y1 is the point where it touches the newly drawn circle, not this circle, right? Sorry, mistake. Please correct that. So it's actually this point, this point, this point. Okay, so that is Y1. Yeah, please read that and tell me how much you get. 0.55. Same value should come, right? Because if you remember, yeah, plus plus J 0.22, correct? Okay, so you know that the B1 value or the JB1, whatever we write, so the JB1 value should be equal to Y1 minus YL, right? So 0.55, 0.55 cancels out, correct? And we have this is plus, the other one is minus of minus is plus. So this is plus J 0. I think 52, isn't it? Right? Okay. So that's the first thing. Then what I do, I'll try to draw a new circle, right, with the y1 and this as the radius. Okay, y1 to the center. We'll keep that as the radius and I'll draw another circle. Fine. Let me see whether this works. Okay, and I'm supposed to move along this circle, right? This is the new circle. I'm changing the color, so I'll move until I touch the unity r equal to one circle. So that is this point over here, correct? Can you see? That will be the y2 form. Okay, read y2 and tell me the value. It should be 1, so only read the x value. Okay, it's 1 plus something, 1 plus j 0.5. So we know that the jb2 can be calculated as this is 1 minus y2, right? So that will be minus j 0.5. Is it okay? All right. So I just have to mark the b1 and b2. So one of them is plus j 0.52. So if this is 0 0.1 2 3 4 5, 0.52 is somewhere here, correct? So that is j 0.52. Similarly, I need a minus j 0.5. So that is below 1 2 3 4 5. So you can see that this is the point corresponding to minus j 0.5. So directly connect this to this point and make a measurement. Similarly, connect the center with this and make a measurement. 0.424 for the bill minus, right? Okay, 0.424 lambda. Okay, and the other one 0.52. Okay, let me check. You may have to zoom in a bit and okay, we don't have a 0.52. We have just 0.55, 0.56. So somewhere in the middle. That's all. Okay. Okay. So that 0.07, correct? Okay. So that becomes 0.074. Okay. Now you see, I just have to measure the distance from this point. Okay. That point is right 0.25 lambda. Okay, fine. So the for the first one, that is the b1 0.52, which is above the in which is present in the upper part of the axis, right? So upper part of the graph. So what I'm supposed to do, I just have to measure the distance. Just let me show. Okay, I just have to measure. You see here till here, it is half, right? It is half in the sense 0.25. So 0.25 plus this number, because this number is starting from 0, right? So that's how. So L1 is equal to, let me just write that. So L1 is equal to, this is my calculation. L1 is equal to 0.25 plus 0.074, right? That is equal to 329 lambda. Okay, similarly, L2 is equal to, apply the previous rule, right? So this 0.424 is actually counted from 0, right? I don't want that. So I have to subtract 0.424 minus 0.25. Perfect. 0.174 lambda. So we got both the required lengths of the stubs. Okay, so that solves the problem.